Hello everyone, this is Ganesh Rubian studying in Sri Venkateswara College of Engineering, and today I'll be taking up the topic typical CNN architecture. Let's brief to the contents. So today I'll be talking about the introduction, what is CNN, different types of CNN, and use of CNN in computer vision, application of computer vision. Let's start with the introduction to computer vision. There are two types of definition. Computer vision is concerned with the automatic extraction, analysis, and understanding of useful information from a single image or a sequence of images. The other one is that it is an interdisciplinary field that deals with how computers can be made to gain high level understanding from digital image or videos. What is CNN? It is a class of deep learning. Convolutional neural network is one of the main categories to do image recognition, classification, object recognition, and face recognition. It is similar to the basic neural network. CNN also have a learnable parameter like neural network, that is the weights and the biases, etc. CNN is heavily used in computer vision. There are three basic components to define CNN. The first one is the convolutional layer, the pooling layer, and the output layer. And today we'll be talking about all these layers. And let me weave through it again. This is the architecture of the CNN. Now let's come to the convolutional layer. Computer read images as pixel and it is expressed as matrix. The convolution layer makes use of a set of learnable filters. A filter is used to detect the presence of specific features or patterns present in the original image or input. It is usually expressed as a matrix with a smaller dimension but the same depth as the input file. This filter is slided across the width and the height of the input file, and a dot product is computed to give an activation map. This is the example of the convolutional layer. The concept of stride and padding. The weight of a matrix moves one pixel at a time and is called as stride 1, as we did in the below case. As we can see in the below image, the increase in the stride value decreases the size of the image. Padding the input image across it solves our problem. We add more than one layer of zeros around the image in case of higher stride values. When the input of the 6 into 6 matrix is padded around with zeros, we get the output with same dimension of 6 into 6. This is known as same padding. The middle 4 into 4 matrix pixel remains the same. Here we have retained the more information from borders and also preserved the size of the image as you can see below. Now let's come to the pooling layer. It can be seen in between the convolutional layers in CNN architecture. This layer basically reduces the amount of parameters and computation in the network. Pooling is done for the sole purpose of reducing the spatial size of the image. Pooling is done independently on each depth dimension. Therefore, the depth of the image remains unchanged. The most common form of pooling layer generally applied is the max pooling, and here you can see the example of it. Now, this is the image where it shows how the pooling is done. The output layer. After multiple layers of convolution and padding, we would need the output in the form of class. The convolution and the pooling layer would only be able to extract features and reduce the number of parameters from the original images. However, to generate the final output, we need to apply a fully connected layer to generate an output out equal to the number of classes we need. Convolution layers generate 3D activation maps while we just need the output as whether or not an image belongs to a particular class. The output layer will have the loss function like categorical cross entropy to compute the error in prediction. Once the forward pass is complete, the back propagation begins to update the weight and the biases for error and loss reduction. Now let's come to the CNN. How to decide the number of convolution layers and the number of filters in CNN? Deeper network is always better at the cost of more data and increased complexity of learning. You should initially use few filters and gradually increase and monitor the error rate to see how it is vary. Very small filter sizes will capture very fine details of the image. On the other hand, having a bigger filter size will leave out minute details in the image. Now let's come to the type of CNN. Based on the problems, we have the different CNN which are used in computer vision. The five major computer vision techniques which can be addressed using CNN are image classification, object detection, object tracking, semantic segmentation, instance segmentation, and learn through these. Now let's come to image classification. In an image classification, we can use the traditional CNN models, or there are also many architectures designed by developers to decrease the error rate and increasing the trainable parameters. Now these are the examples: LeeNet, AlexNet, ZFNet, GoogleNet 19, VGGNet 16, and ResNet. Object detection. Here, the implementation of CNN is different compared to the previous image classification. Here, the task is to identify the objects present in the image. Therefore, traditional implementation of CNN may not help. So, here are the list that may help: RCNN, Fast RCNN, Faster RCNN, and YOLO. Now let's come to the last topic: applications of computer vision. Computer vision, an AI technology that allows computer to understand and label images, is now used in convenience stores, driverless car testing, daily medical diagnostics, and in monitoring the health of crops and livestock. Different use cases found in computer visions are as follows: retail and retail security, automotive, healthcare, banking, agriculture, and industrial. And this is how I end my presentation on typical CNN architecture. Thank you, everyone. Have a nice day.